So if you did not write this down, maybe you can do so after with the video. Okay, so maybe don't rush too much because I want to dive into our first example. But this is steps to interpret and graph word problems, right? So we introduce our variables, x and right, there'll be two variables. State the implicit constraints, restrictions. So you can state it in either way. Write the inequalities presented. There should be an inequality for each restriction mentioned. And I will show you how you can identify the restriction that is mentioned in the question. 4, obviously we graph them. So by the time you get to 4, we have done that over and over again. We've been graphing a lot. Except for when it's a word problem, we only stick to quadrant 1, which makes it actually a bit easier, to be honest. So do not extend the lines, okay, past the first quadrant. Then we'll state all the POIs, and we will round if data is discrete. Most of the time it will be discrete. Sometimes it's continuous, right? Depends on the situation. I will add a 6th step here, right? State a possible solution. Comma, found in the solution region. Okay, and I'll do that at the end. So once you have your solution region, can I say next to solution region, sometimes a textbook or some of the worksheets, feasible region, same thing, feasible solution region, it's where the solution is found or can be found. Sometimes when it's asking you to graph, it's going to ask you to graph the solution set. It's like, what is a solution set? It's basically just graph it. Just graph it and find where the solution region is found. Okay, so I'm going to start with a word problem. And we're going to start today with just one inequality. Like you'll only be able to find one inequality in the question. Okay, and then tomorrow we'll do 2 and 3. And 3 is basically where it kind of ends. So keep that in mind. All right, so here we go. I can zoom into this section here because that's basically where I... Okay, so example, okay. A certain manufacturer makes scarves and toques. It takes 15 minutes, bless you, to produce a scarf and 10 minutes to produce a toque. The company has up to 2 hours of production time. Available. Graph the solution set. State the POIs and give a possible solution. Let me try to focus one more time here. So I'm gonna put little numbers next to the steps I'm going through just to show you, right, with that it coincides with the steps I just gave you, those 6. Okay. And so the first thing I want you to realize is you need to define your variables. I will probably ask you to do that on a quiz or on a test, but define. So we let X be something and we let Y be something. Okay. And in this case, most likely you'll find it at the very beginning, right? That we are making scarves and toques, right? And I usually let the first thing be X and the second thing be Y. So in this case, we can say it's the number of scarves, and Y would be the number of toques. Okay. So let that is all done. And then the second thing that I'm going to do right next to it is just say that X and Y have to be greater than or equal to 0. And what kind of data is this? If it's number of scarves and number of toques, between continuous and discrete? It's discrete, yeah? So this is just for you to know when does that come into play when you're finding your POIs, your points of intersections. If it's discrete, you're going to need to round them, okay? That's why I write that down, so that later on you know where to look for. So we've done that. Number 3, the step number 3 is find the inequalities. Okay. I will use a different color highlighter to show you where the restriction is. And it has to do with those keywords. And it's actually found right here, right? It tells you how long it will take to produce each item, but then here it says the company has up to 2 hours of production. Up to. That right there, to me, right, and to you, should tell you that that's a restriction. Restriction. There's a restriction on the time available, okay? So you have up to 2 hours. So what I'm going to do here is this, right? There's a restriction. You won't do this down the road, but right now, right? Restriction on time, right? Up to, you can also say maximum 2 hours available. Right? You should be comfortable switching it up, saying up to, it's also max of 2 hours. So we will say this. You look at that there's a restriction on time. We are given the time it takes to produce each item. Okay, so these are the coefficients that go with your variables. So if it takes 10 minutes to produce a scarf, 15, my bad, it takes 15 minutes to produce a scarf and 10 minutes to produce a toque. And which way do I have to put my inequality symbol? That's always the kicker here. This has to be less than or equal to, right? The amount of toques and scarves you're producing, that has to be less than or equal to, what are we going to put on this side? Can we put 2 down? It's going to be a problem because this is minutes and minutes. So just quickly, we're just going to say 2 hours is the same thing as 120 minutes, right? And so we actually, I prefer to, you either use hours or use minutes, but you can't use both. Okay, so that is this one tells us that in this problem, it doesn't matter the amount we make, right? You have to make sure you stay under the 120-minute time limit, okay? So fourth is graph. So we're gonna graph our set here, and you grab a ruler, and we're sticking to the first quadrant. So it's basically just like this. And I'm going to be very picky on labeling here. Okay, so X, you just told me it's the number of scarves. So actually, don't just put scarves, say it's number of scarves. Because down the road, it's going to be time. Is it time in minutes, time in seconds? What is it? But in this case, X represents the number of scarves. Right? It doesn't make sense, minutes of scarves, right? It wouldn't make sense. It's the number of scarves. And then up here, we put the number of toques. And now you need to come up with a scale. So this is where you come in, right? I probably should have left a little bit more space, but I can do all of this here. I'm going to find my X-Intercept and the Y-Intercept, because when you want to graph it, you need that, right? So 15x is equal to 120. Divide both sides by 15. And today, for this thing, you just write it down, right? 80 is the intercept, X-intercept. And then we have 10y is equal to 120. Divide both sides by 10. And in this case, it's nice, all nice round numbers. We love that, right? So let's try to be careful with our space here. So 10y is less than or equal to. The 15x comes over subtracting. The 120 is already there. With word problems, it'll be rare that you have to divide by a negative. It'll be it'll be here and there, you might have a case, but it doesn't show up. So students tend to forget that that is actually still happening when you go back to just graphing a non-contextual question, right? So we have this here. This is a solid line. Most of the time, it'll be solid. The true region is below, so we shade above. And you're like, this isn't a system, Mr. Dirksen. I would just like to stick with reverse shading. I don't like to jump back and forth too much. So most questions are going to be systems anyways. Most word problems will end up being systems. Okay. So I look at my intercepts. I need to go up to 8 and up to 12. So that's doable. So I'm going to go 2, 4, 6, 8, 10, 12. That's good enough. Okay. Lots of space there to graph that. And let's see here. 2, 4, 6, 8, 10, 12, 14, right? Yeah, so that's good. The spacing is different, but that's fine as long as you keep it the same in that on that axis, right? So then it's 8, 0, 0, 12. You graph that line. So what I want you to focus on today and after this class is just making sure you get the basics right. Okay. You can label it. I allow you to label it like this because sometimes it gets crowded. So if you just go out like that and somewhere, just tell me that that line is represented by that inequality right there. So I'm going to shade above, put my ruler right there. So this part, I'm sure a lot of you are like, yeah, I know how to do this part. I know how to graph. Okay, but just wait, hold on a bit, stay with me. You don't have to fear it, you just have to try these, okay? After a while, you're gonna be pros at it. This is my solution region. So make sure label, scale. My line has no arrowheads, it didn't go past the axes. All that needs to you need to make sure you don't do that, okay? The only one that has an arrowhead is if you have an X line, like a vertical, and it keeps going up. That one you can have an arrowhead on. Or a horizontal line that keeps going to the right. You can do that, okay? So let's find the points of intersection. In this case, you can read them all off of your graph. Every single one of them. So we have 0, 0, and you might think that's a little bit irrelevant. True, but that is the surrounding your solution region. 0, 12 and 8, 0. Right now you're going to be like, I know that, Mr. Dirksen, no big deal. So I'm just going to say I read this one, right? You just read that off the graph and there's no calculator. You didn't have to type anything into your calculator yet, but that is coming, okay? They're all round whole values, whole numbers, so you can keep them as is, okay? So this would be step number 5, by the way, okay? Step number 5 is stating all of the POIs. And step number 6, give me a possible solution. Please don't pick 0, 0. That one is a bit lame, okay? So anything, like you can say this is 2 and 6, right? 2, 6. It's in the solution region. That would work, right? So how about this? We just first write a possible solution, because this can vary from student to student, right? A possible solution is, I'm going to go 2, 6. So basically just look at your graph, right? 2 is here, 6 would be right there. It's definitely in the solution region. 4, 4 would have worked as well. So what does that mean, right? Producing, this is where you need to have a statement. 2 scarves and 6 toques is a possible solution. Okay, so you need to now switch from just it being a point to now this coordinate meaning something, right? It represents the number of toques and the number of scarves, okay? I should say that again. Scarves is the two, toques is the second. A couple of things here. If you mistakenly, or not mistakenly, you just read it differently. Let's say you let X be the number of toques and Y the scarves. Your graph will just be different, right? It'll be flipped, and that's fine. You don't have to do it exactly the way I do it, so you don't have to worry about that. Okay. Now I'm going to ask you to, let's try one more here. I'm actually, how about this? Because there's quite a few, I have quite a few of them. Can you take your worksheet booklet for this unit and go to page 7? I'm just going to work off of those. So in your notes, right, I'll just say see more examples on page 7 and 8. Okay. More examples on page 7 and 8, so then you know. But to be honest, this is going to be short-lived. Like tomorrow we're going to do 2 or more. So I'd rather, instead of spending too much time writing this down, I'd rather you just go straight to page 7. And let's do a little bit of an experiment here, or a trial and error perhaps. Just for the first page on page 7, I want you to figure out, like, define your variables in that case, state your implicit constraint, and then come up with the inequality that would describe that situation on page 7. Just do page 7 right now. So I'll give you a little bit of time. Define your variables, state the implicit constraint, which is always x is greater than or equal to 0, y is greater than or equal to 0, and then make an inequality that would describe the situation. All right? So go give that a try. I'm coming back and going over it. You forgot your booklet? Yes, maybe. Let me see if I have another one. 1 second. I might have another one. Answer. But it is all about the work and the process and whether or not you're consistent. Okay. So I'll say one more thing before I continue here. So I'm going to go back to the first one. So these steps that I just gave you, these steps are a guide, right? Like, let's say there's just a word problem. They're like, hey, solve this thing. Basically, what you need to do is all of this to be able to finally state a possible solution. You need to go through these steps. But I will most likely on a test or a quiz guide you through them anyways. I'll say, hey, here, write the inequalities, define them, right? So you get marks for each individual step. So you don't have to worry too much about memorizing the whole thing, but it's just to know, okay, if nothing was said, then that's what you need to do, okay? So here we go. A company makes motorcycles and bicycles. That right there is setting up the scene for you. It's nice, short and sweet, right? So motorcycles and bicycles. Pretty good hint that those are going to be my variables. And they make no more, there's that word, no more than 400 vehicles in a week. Okay? So in this particular case, you let X be something, Y be something. And I'll give you a little, watch this. This is a tip, a trick, right, that I use. I have a pretty good feeling it's going to be motorcycles and bicycles. So you can go ahead and write that down, right? Motorcycles and bicycles. Okay, so you have to state it like that. Then you just quickly say that X and Y, they both have to be positive because we're dealing with a word problem and you can't have negative of them, right? And here's your inequality, right? No more than 400 vehicles per year. There are no other numbers here. Do you notice that? Earlier we had like the 10 minutes to 15 minutes, right, for time. So all you need to do here is X plus Y, the number of vehicles, can be no more than 400. So this combination has to be less than or equal to 400. That's all you do there. I will do the graphing in a little bit. I'm more interested right now in coming up with this because I know you know how to graph. And this is the trick here. What is 400, right? 400 is the number of vehicles. So it does make sense that this is the number of motorcycles and the number of bicycles, right? So I will go back up here and be more specific. I should have given myself a bit more space, but I will do this. Number of, right? Y is the number of bicycles. So it's not just, right? You need to be specific, like what is it? The number of. Okay, got it, right? Let's do the second one here. I'll walk through the steps again. Sam wants to spend 10 hours studying for her math and science exams. There is that up to 10 hours, so that tells me that there's a restriction, and there's a math and science exam. So we will let X be something, Y be something. I'm pretty sure that this is going to be math, and this is going to be science. But is it going to be the number of math exams and the number of science exams, or what is it going to be? And this is the trick here. State your implicit constraint. Don't forget about that. You lose half a mark if you forget that, right? So just mention it. And then I say that, okay, something added up is, I only have 10 hours, right? So X and Y, right? I have up to 10 hours to spend studying for them, right? So the combination has to be less than or equal to 10. What would you say makes sense for these variables to represent? This is the number of hours, right? 10 maximum. So X would be the hours, right? Hours, and I did it again. Studying math. Sorry, guys. You should have seen my notes in high school. That was something you will never forget. Anyways, hours studying math, hours studying science. And I kind of went math, science, yes. I'm pretty sure that it is that, but what? Is it hours? Is it the number of math exams you're taking, right? So in this case, because of this statement, we could backtrack and say it only makes sense that they represent the hours studying for each subject, okay? Let's go to the third one here. A dealer can purchase touring cycles for 300 bucks, right? So there's touring cycles and racing cycles. I don't know if you noticed that. Variables. And I'm going to use a different highlighter and say that it costs, right, 300 bucks to purchase that, and it's 400 to purchase the racing cycles. She plans to spend no more than 8,400 bucks. No more than $8,400. So there's more going on here, right? So let X be, what would you say X is? Touring cycles, right? I might have to change it, but for now I'm just keeping it. And this one is racing cycles. So it's the little things that I want you to What happened here? There. Cycles. Okay. And then we're going to go and just state this. Okay. And let's come up with our inequality. It has to do with money. The restriction has to do with money. So we have to use the money amounts that go with each variable. So if it's $300 for the touring cycle and $400 for every racing cycle, right? That combination, like whatever combination, that would have to be no more than $8,400. So it's less than or equal to $8,400. That is, in this case, that is the inequality you're supposed to write. Okay, so sometimes it's just x and y. Sometimes x and y have a coefficient in front of it. So can I just go back? In this case, it only makes sense to say the number of touring cycles and the number of racing cycles. Okay, so I'll just do this, number of, okay? So number of touring cycles, number of racing cycles. So you've made very clear that you know what they represent. So if the dealer bought one of each, one touring cycle and one racing, that would be $700, right? That would actually make the statement true, right? And so that's how you come up with that. Okay. We still have some time. Let's do the back. I'm just going to peek at the back. I'm not going to actually do it. Okay, so that is going to be your homework. Page 8 is going to be your homework. Okay. So I'm going back to 7 now, though. Sorry for the back and forth. So 8 is going to be your homework. There's 4 more questions there. I would suggest do it on loose leaf, but it is possible to fit it on here. I'm going back to the top one because I want to talk about scales, because now the numbers are going to get bigger. Okay. So when you have x and y like that, that is gold for you. Okay. You can actually say that this is going to be 400, 0, and 0, 400. Like, you don't need to do the whole big x-intercept, y-intercept chart, because if y is equal to 0, x is going to be 400, and if x equals to 0, y is 400, right? So immediately you know your intercepts. Let's rewrite it one more time, right? The x comes over negative, and then you add 400 to it. This is an important step to do every time, okay? You still want to be doing this because you need to know where to shade. And later on, when we have more than one, you need to find points of intersections, okay? So this is a solid line. The true region, because it's less than, lies below the line. So we will shade above, okay? Hope you can see that. Looks all right to me. So I will make this work, this space. So I'm going first quadrant, okay? So this is number of motorcycles. On the x-axis, this is number of bikes. So get that out of the way. And look at my numbers are big. So I'm going to go 100, 200, right? 100, 200, 300, 400, and they will get bigger. Okay, so no big deal. You just need to adjust your scale accordingly. So I'm going to do the same thing here. Maybe have them closer together. But I want you to spread out, right? Like, spread it out. Don't have it too cramped, because you want to see the lines. So it's 400, 0, 0, 400. I'm shading above. Okay, I write my solution region. I label the line. You can use the label you prefer, the original inequality or the one you rewrote. They're all the same. That would be a graph, right? That's all you need. You have a scale, you labeled everything, solution is there. POIs, I'm going to do the POIs right up here because it's not going to require that much space. So 0, 0 is the easiest one here. 0, 400. Order doesn't matter. And then this one here is 400, 0. So those are my POIs, right? And as I said, like if you do it on loose leaf, you have more room. A possible solution. You can pick 100 and let's do 150, right? 100, 150. So they can make, right, produce 100 motorcycles and 150 bikes. Will work. Okay. By the way, some of you are asking, Mr. Dirksen, why aren't you picking one of the POIs? Absolutely, you could. You could pick this one here and say only making 400 motorcycles will do. Only making 400 bikes because this is a solid line. So anything along the axis will work. Anything inside the solution region will work. Anything along this line will work. Okay. That is basically it. And so I'll let you have the rest of today. So tomorrow we'll do, yeah. Question? Avril, yeah. If it's a dashed line, then you couldn't. No, you couldn't because right, like if there's a dashed line, but you know what? It happens. Like I think there's one example where you have a dashed line, and the whole like everything that I'm going to assign, most of them are solid. Yeah, it just makes it very complicated if they're dashed. So the textbook doesn't have either. Did I tell you the homework right? Page 8. Please, like I'm just gonna give you an advice here. This unit, like if when we do many at a time, it gets overwhelming sometimes. So this is good practice to read, come up with the inequality, graph it, and do like just go through the motions of picking a good scale, all of that. Tomorrow we'll do 2 right away, okay? I'll probably have a short AC, just one inequality like this. It might even be a random one picked from one of these questions, who knows? And just watch out for units. And I have the key already posted.